Okay, so I want to launch forward into T-scores as opposed to Z-scores. And I honestly think these are pretty easy, easier than what we've been doing up until now. But in order to do this, let's trace a little history, okay? In reality, we rarely know what the population standard deviation is. So in the past, when the sample size was large, and you'll remember at one point we said that all of our normal CDF and inverse norm stuff that we were doing prior to the test, generally you wanted a group of a sample size of 30, 40 or more. Well, when you get a sample size that big, the answers are so close with the confidence interval that statisticians didn't have a problem with it. But they did have a problem when the sample was small. A small sample size caused inaccuracies in the confidence level. So there was this guy, William Gossett. Not only was he a great beer brewer, and I don't even drink beer, but apparently a lot of people like Guinness beer, he ran into a problem. His experiments with hops and barley produced very few samples. So if he just replaced the standard deviation, normal symbol, with S and divided by the N for the sample size, he didn't really get accurate results when he tried to calculate a confidence interval. He realized that he could not use a normal distribution. So what he did, because, what he discovered was what we call the student's T distribution. Now, before you think student means students in classes, Gossett wrote as a pen name under the pen name student, okay? So up until the mid-70s, some statisticians used the normal distribution approximation for large sample sizes and T distributions only for sample sizes of at most 30. With graphing calculators and computers, the practice now is to use the T distributions whenever you're going to use S, which is N minus 1, as an estimate for the standard deviation. If you draw a simple random size of size N from a population that has an approximately normal distribution with a mean of mu and an unknown population standard deviation of rho, and calculate the t-score, it is. Now that's the same formula that we always use, except because we're getting into means and everything, instead of putting the standard deviation on the bottom, we're putting the standard deviation divided by the square root of n. This is now the third time we've applied that. Then the t-scores follow. A student's t-scores with n minus 1 degrees of freedom. A t-score has the same interpretation as a z-score. It measures how far the mean, how far mu is, x bar is from its mean mu. For each sample size n, there's a different t distribution, okay? So that's just a little bit of background. You're not going to be tested on that stuff. But here are some properties of the t distribution. The graph for a student's t distribution is similar to the standard normal curve. Of course it is. The mean is 0 and the distribution is symmetric about 0, okay? That's a lot like what we were just working with in the confidence intervals, because if you remember when we did our inverse norm, the mean was 0 and the standard deviation was 1. The student's t distribution has more probability in its tails than a normal distribution because the spread of the t distribution is greater than the spread of the standard normal. So the graph of the student's t distribution will be thicker in the tails and shorter in the center than the graph of a normal distribution. But it still has the shape of a normal distribution, so the concepts contained therein, with a little tweaking, can be viewed as similar. The exact shape of the t distribution depends on the degrees of freedom. As the degrees of freedom increase, the graph of the t distribution becomes more and more like the graph of the normal distribution. The underlying population of individual observations is assumed to be normally distributed, with unknown population mean mu and an unknown population standard deviation. The size of the underlying population is generally not relevant unless it's super small. If it's bell-shaped, then the assumption is met and doesn't need discussion. Okay. So how do we apply this? Look, we've talked about a lot of things, and you probably scratch your head going, oh my God, you're giving me a headache. It's really not hard to apply. I just wanted to make sure we went over that stuff. Okay, the big thing to get from that is that when you get small sample sizes, 10, 12, all the way up to about 30, t-scores are really the way to go compared to z-scores. So small sample size, t-scores. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. And let me tell you something. I get acupuncture treatments and nothing, absolutely nothing. I've got great massages. Nothing in the world makes you more relaxed than an acupuncture treatment. At least makes me more relaxed than an acupuncture treatment. You measure sensory rates for 15 subjects with the results given. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population, assumed to be normal, from which you took the data. The solution shown is a step-by-step using the TI-84 Plus calculators. Now, if you remember at the end of the last lesson, we showed you how to find the mean on a graphing calculator. So let's do that again. We're going to go to Stat and then Edit. And then you're going to clear out list one, go all the way up to the top with the cursor, hit Clear, Enter, and then that'll kick the cursor below the top bar that separates the heading. And then you're going to input all of these values, 8.6, 9.4, 7.9, and so on. When you get to the last one, you're going to go to Stat Calc, hit the Stat button. First over the top is to Calc. It'll say one variable stats, hit Enter, and then X bar will kick up, and that tells you what your mean is, okay? All right. So once you have that mean information, this is how you find the T-scores. It's really a whole lot easier than you think it could be, all right? And I'm actually going to go through this with the calculator exactly as I'm explaining it to you. You want to hit Stat, and then you're going to want to go over to Test, which is the third row over, okay? Or the third column over, I should say. Now, if you look down on the screen, you will not see t-tests or t-intervals. Or t-interval, I'm sorry, you won't see that. So you go down until you hit number 8, and it says t-interval. Press Enter. And the input, it says data. And the data you want to input is the list 1 that you just made in the calculator, because that's all of those numbers you just put in. And you'll notice data is blinking, saying, I want you to input the data. And if you go underneath that, it says list L1. So just go down 1 unit and you get another blinking cursor on L1. Hit Enter. We just leave the frequency at 1. And then it says C level. That's confidence level, okay? In this particular problem, it wants the confidence level to 95%. So you hit 0.95. And then you go down to Calculate, hit Enter, and out pops this beautiful my answer wasn't so beautiful. The one is after frequency, enter 0.95. Let me do this again. I must have had a mistake here. Ready? Stat. Test. Down to number 8. Enter. I want list 1. List 1 is in. Oh, I know what my problem is. I have a different list 1 than I'm supposed to have. Okay, so you have this list 1 in. So you're good with this list 1. Arrow down to C level and you put in 0.95 because that's the confidence level that you want. And you hit enter, calculate and enter again. I had done this before and came out with these answers. And it tells you the confidence interval level is 7.3006 and 9.1527. So listen, it's the guy in the calculator, the guy waving the magic wand of a TI-84 that pops out the answers. All you need to do is know how to press the buttons in the calculator, know what commands to give it at what particular point in time. Okay? So this time, we're going to do a study on hypnotherapy to determine how effective it is increasing the number of hours of sleep subjects get each night. You measure the hours of sleep for 12 subjects, that means n equals 12, with the following results. Construct a 95% confidence interval for the mean number of hours slept with the population, assume normal, for which you took the data. Okay, so there's your list 1 input. Put it all in, calculate the T-score. Okay, remember you're going to go stat edit. That'll put all these values into list 1. Then you're going to come out with that and go over to stat tests. Oh, and don't forget, I don't even think you're going to need the mean. If you need the mean, you go to stat calc. Okay, good. Okay, assuming that you did stop and start, first thing you need to do is put all that data into L1. I assume that you have done that, okay? And once you put that data into L1, you have to remember, get that, to change that list in L1, make sure you get the cursor all the way up into the top and hit clear enter. Then you put all the data into L1. And once you do that, you go to stat tests. You go down to option 8, T interval, because you're using the interval, the confidence interval for certain T-scores. Then you arrow down to data and you want it to say L1 for that list. So you hit enter. Right where it says list is L1. That's the part that you hit enter. Remember, you go down from data. And there should be a 1 after frequency. Assuming the 1 is there, just hit enter. Then it says you got to go to C level, which means confidence level, and you wanted a 95% confidence level, so put in 0.95, and then hit enter. And it will tell you, again, the calculator's doing all this work. You're just hitting enter, enter, enter. It'll tell you in the calculator that you go from 8.1634 to 9.0 or 9.8032. Okay, so that's the step-by-step on how to get T-scores. It's a little strange, but it's easy to follow. Remember, first step, you go into list 1, put all the data in there, make sure you clear it, then put the data in. Then you go to stat tests, choose option 8, which is the T-score interval of confidence. Then just start working down the screen. You go to data, you look underneath that, it should say L1, go down to L1, hit enter. Once you do that, there should be a 1 after frequency. Every time I've ever done it, there's always a 1 after it. If not, I don't know what you would do, but I think there's a 1 after frequency. If not, put a 1 in there, hit enter. Then it says down to confidence level, so you want to arrow down to the C level, and in this case, you want 0.95, so enter 0.95, and then hit calculate, and then enter again, and it'll tell you the confidence interval is 8.1634, 9.8032. So you're really not even doing a ton of math. What you're doing is you're knowing how to program the calculator, and the calculator is doing the math for you. Okay. Now let's just very quickly compare T-scores and normal curves and what there is about them that's similar and what there is that's different. Okay. A T-score is similar to a normal curve. A Z-score comes from a normal curve. A T-score is for small sample sizes. This is the biggie right here. Sizes 30 or less. Z-scores are for larger sample sizes. T-scores measure how far the mean is from, the different types of mean are from each other. Same thing for the Z-score. For the T-score, you always have a mean of 0 and you're symmetric about the mean. In Z-scores, the mean can vary, but it's also symmetric.